So first you can write now the fx. We have fx is equal to a0 by 2 plus infinity n is equal to 1 an cos nx plus infinity n to 1 infinity summation bn cos sin nx. So this is the basic formula. Here fx is equal to x, that is given in the question. Again, now x has the formula a0 by 2 plus n is 1 infinity an cos nx plus summation n is equal to 1 infinity bn sin nx. That means this is the, in case of the x we have for the fx, in case of fx we have for the x. This is equation number 1. Now a0 an bn, we have to determine the value of a0 an and bn. Now so first we determine the values of the a0. So a0 has the formula 1 by pi integration 0 to 2 pi fx dx. So in case of the fx we have to put the x. So 1 by pi 0 to 2 pi x dx. So now integration of x, that value will come, that is your 1 by pi x square by 2, and we have the definite integral 0 to 2 pi. Now we will substitute the value in place of the x. 1 by pi, this will be 2 pi square, that will be your actually directly I am written 4 pi square by 2, and 0 square is equal to 0. So now it will cancel 2 pi. So now determine the values for an. So an has the formula 1 by pi 0 to 2 pi fx cos nx dx. This is the formula. So now in place of that fx we have to put the value of x, 0 to 2 pi 1 by pi 0 to 2 pi x cos nx dx. Now we have to use the formula there, 1 by pi and 0 to 2 pi cos bracket will give cos nx into x dx. There we have to put cos nx dx into x, we can write there, minus again 0 to 2 pi integration, then integration cos nx, integration cos nx dx into dx by dx into dx. It means integration of u into v dx. So 1 by pi bracket integration sin nx by n and x. Now definite integral from 0 to 2 pi minus 0 to 2 pi cos nx dx, that is your sin nx divided by n, dx equal to 1. So close the bracket. Now 1 by pi is equal to bracket, there we have to put the value of 2 pi in case of your x, 2 pi n divided by sin 2 pi n divided by n. There you can also, for another x we can write the value of 2 pi. Now it will be integration of 1 by n, that value will be, value for 0 will be 0. Now 0 to 2 pi sin nx by n, that is your sin nx dx. 1 by n we have taken the common. Now 1 by pi into 2 pi sine 2 pi n divided by, that is n, minus 1 by n minus cos nx divided by n. There the definite integral of 0 to 2 pi. Now it is bracket, that is 1 by pi multiply to whole bracket. So now 1 by pi, this is your 2 pi sine 2 pi n divided by n minus minus and minus plus, that will be, now it will be cos nx by n n square, that is 0 to 2 pi, n into n is equal to n square. So now 1 by pi 2 pi sine 2 pi n divided by n plus cos 2 pi n divided by n square minus cos 0 by n square bracket, and the end for whole bracket is equal to 1 by pi 2 pi that is your 0 by n plus 1 by n square, this will be also 1 by n square. So now 1 by pi into 0, 1 minus n square and minus n square equal to 0. Now the value will be 0, n the value will be 0, because the sine 2 pi n has the value 0 and the cos 2 pi n has the value, that is your 1. So this is the value. Now we have to determine the value of bn. So bn has the 1 by pi formula, that is integration 0 to 2 pi, then fx sine nx dx. Actually that is your sine nx dx, that is your 1 by pi 0 to 2 pi x sine nx dx. So now you have to find 1 by pi 0 to 2 pi sine x into x dx. Actually this is n nx dx. So now you have to again use the formula 1 by pi 0 to 2 pi, that is sine nx dx into x minus integration 0 to 2 pi integration sine nx dx into dx by dx into dx. This is the integration of uv formula. So 1 by pi, that is sine nx dx, the value will be minus cos nx by divided by n into x integration, the definite value will be 0 to 2 pi. Now 0 to 2 pi integration sine second, it will be minus cos nx divided by n into ds, ds by ds is equal to 1, the bracket complete. Now 1 by pi minus cos nx, value will put here, in place of the x we will put the 2 pi minus x cos nx by n minus bracket 0 to 2 pi minus 0 to 2 pi, we can write this minus into minus, that is plus. Now 0 to 2 pi, this is your cos nx divided by n dx, and close the bracket. 1 by pi, value will put minus 2 pi 1 by n into minus 2 pi cos 2 pi n. Again I am writing this 1 by n n cos x n s 0 to 2 pi, later on we will put the value. Now sin nx divided by n 0 to 2 pi. Okay, so now 1 by pi 1 by n x 2 minus 2 pi n cos 2 pi n, that value. So minus, that is your value will be 0 x, the value will be 0, plus 1 by n sine nx 2 pi x 2 pi n divided by n minus sine 0 divided by n. You can write that divided by n and close the bracket. Now it will be 1 by pi 1 by n minus 2 pi by n cos 2 pi n has the value 1, so it will be minus 2 pi by n plus 0, and this will be 1 sin 2 pi n is equal to 0, so that value will be 0. So lastly we get minus 2 pi n is equal to 0, so this side it will be 0. So now we cancel each other, pi and pi, this value will be minus 2 pi by 2 by n. This is the value of bn. Now we will get the bn value is equal to minus 2 by n. Substitute the value of a0, an and bn, that is in equation 1, that is x is equal to the equation we have in equation 1. Now the value of the equation 1, x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus 1 to infinity bn sin nx. Now we are allowed to put the value of a0, an and bn in place of in the equation. So now it will be 2 pi by 2 and 1 to infinity, the value of n is 0 into cos nx plus n1 infinity bn sin nx. You can put the value of bn also here. So now 2 pi by 2 plus n1 0 infinity 0 cos nx plus infinity and 1 to infinity, that is the value of bn is minus 2 by n into sin nx. So now the value of 0 into cos nx is equal to 0. So now 2 cancel to each other, 2 cancel to each other, now it will be pi plus n1 infinity minus 2 by n sin nx. Now it will expand the value of minus 2 by n sin nx. So x is equal to pi minus the value of n we have to put here 2 by 1 sin nx minus 2 by 2 sin nx. Value of n will be put in because it is from the 1 to infinity. So now x is equal to pi minus 2 sin x minus sin 2x minus 2 by 3 sin 3x. This is the required equation, and this is the Fourier series for this solution for the question. It's the required equation.